Hello everyone, myself Ami Mehta, and let us discuss the error detection and correction method in the link layer, which is a service provided by data link layer. And we discuss here is the parity check method for the error detection. So let us discuss it. So in parity check method, in this technique, a redundant bit called parity bit is appended. So the extra bit is added, which is called parity bit, to every data unit so that the number of ones in the unit, including the parity, becomes even. So let us understand this by example. For example, the data is 00111. So this is for example data. Now we add 1 such that this number of ones become the even. So I add one parity bit 1 so that the number of ones become even. So including the parity becomes the even. So block of data from the source are subjected to a check bit or parity bit generator form, where a parity of 1 is added to the block if it contains an odd number of ones, and 0 is added if it contains an even number of 1. So for example, here odd number of ones are there. So we are added 1 as a parity bit. So the number of ones become even. But if, for example, the data is 0, 1, 1, 0, 0, 0. Now again the number of ones here is even. So as a parity bit we include 0 so that the number of ones is remain even. Okay. So our goal in this parity check, that after adding parity bit the number of ones become even. Okay. So at the receiving end the parity bit is computed from the received data bits and compared with the received parity bit. So again it is compared with the received parity bit. So this scheme makes the total number of ones even. That is why it is called even parity checking. So what we are doing in this method, that we are creating total number of ones even. So that is why it is called even parity checking. So here is the method of how actually parity checks will work. Okay, so here send the data. So data is 1 0 1 1 0 1 1. So the total number of 1 here is 5. It means that the total number of ones is odd. So if we want to compute parity bit, we are facing that the total number of ones present is odd. That's why we have to add as the parity bit 1. So 1 0 1 1 0 1 1, and we add 1 as a parity. So now this including parity data, the number of ones become even, and that data we are sending to transmission media. Now what it do? Here it compute parity bit. So it compute parity bit as 1, and it checks it is that it is even. If it is even, it means that the data is found corrected, means the received data is correct. That's why it accept data. Otherwise, if the for example here error occur and the 1 0 and this third one is become 0, is changed due to some error. So 1 0 0 1 0 1 1, and its parity. Now the total number of 1 here is 5, which is not even. That's why it rejects the data. So this is the method actually how parity check will work. So performance of parity check. So a receiver can detect all signal bit errors in each code word. Errors in more than one bit cannot be detected. So for example, here we see that this bit is changed to 0. So this is a 1 bit error. So the 1 bit error can be detected. But if this one also becomes 0, now what is the scenario? That the number of 1 is even. So it accept data. It means the data is with error. Then also it accept the data because it is a error of 2 bit. So it only identify the 1 bit error. But errors in more than 1 bit cannot be detected in parity check method. So in parity check, the concept is to made one as even. So that's why we called here is even parity checking. If we are doing odd, so for example, if we are counting total number of ones as a odd number, the total number of one should be odd at the end of parity check, then this method would be odd parity checking. Okay, so now what we can do for two-dimensional error? So for that it is two-dimension parity check. So performance can be improved by using two-dimensional parity check, which organize the block of bits in the form of table. So parity check bits are calculated for each row, which is equivalent to a simple parity check bit. And parity check bits are also calculated for all columns, then both are sent along with the data. Now in this method we only detect 1 bit error. More than 1 bit error we cannot detect. So for that we use two-dimension parity check. At the receiving end, these are compared with the parity bits calculated on the received data. So here it is the example that original data is 10110011, 10101011, 010111010, and 11010101. Now what we are doing, so in this we partition the data. So in this bit we are partitioning it. So now in this row, so total number of ones here 1 2 3 4 5, so it is odd, so we are adding 1, that's why the total number of 1 become even. Then in second row 10101011, so the total number of 1 is 1 2 3 4 5 again, so we are adding 1, so total number of 1 becomes even, which is 6. So in third row, total number of 1 is 1, 2, 3, 4. So it is already even. So that's why we add 0. In the last one, it is 1, 1, 0, 1, 0, 1, 0, 1. So it is 5 again. So we add parity as 1. So that the total number of 1 become 6. So this is row parities. This is one dimension. Now we also check for the column parity. That 1101, so total number of 1 is 3, so we are adding one more 1. Okay, in the next column total number of 1 is 2, so we are not adding 1 as a parity, but we are adding 0. Third column, same, the total number of 1 are 2, so it is already even, we are not adding parity as a 1. And here in fourth, it is the number of 1 is 3. So we are adding 1 to it. So it becomes even. In the next column, the total number of 1 is 2. So we are adding 0 as a parity. In next column, it is a total number of 1s is 1. So we are adding more 1. So it becomes, total number of 1 become 2. In the second last column, the total number of 1 is 3. So as a parity, we are adding 1. And at the last, again, the total number of 1 is 3. So we are adding here 1. Okay. So now what actually sending here? This is the data. This is the data. But here at the end, we are adding this 1, 0, 0, 1, 0, 111. And the 1 bit from this. Now we again calculate the column parity for this calculation of row parity. So this is our row parity 1, 1, 0, 1. So total number of 1 here is 3. So to create even number of ones, we are adding here as a 1. So this is the answer of row parity's value. And this 1 is added here at the last. So this is the how 10010 and 4 times 1 actual data is sent. So this data is sending from sender side and receiving side. Again it checks for the parity. If it matches, then it accept the data, otherwise it not accept the data. Now let us discuss the performance of two-dimensional parity checking. So the two-dimensional parity checking increase the likelihood of detecting burst errors. So 2D parity check of n bits can detect a burst error of n bits, or a burst error of more than n bit is also detected by 2D parity check with a high probability. So if 2 bits in one data unit are damaged and 2 bits in exactly same position in another data unit are also damaged, then the 2D parity checker will not detect an error. So there is again limitation of 2D parity check, that if 2D bits in one data unit are damaged and 2 bits in exactly same position in another data unit are also damaged, then this 2D parity checker will not detect an error. Okay, so this is all about parity check method in the error detection. Okay, thank you.